Sixth problem E bit, given f of x as x plus 1 whole cube of x minus 3 whole cube. So, f dash of x is equals to, now let us apply product rule to find the differentiation, which is x plus 1 whole cube into differentiation of x minus 3 whole cube is 3 times of x minus 3 whole power 2 into differentiation of x minus 3 is 1 plus x minus 3 whole power 3 into differentiation of x plus 1 whole cube is 3 times of x plus 1 whole square into differentiation of x plus 1 is again 1. Now, to find the turning point, first let us simply equate this one to 0 and we simplify this one, equating this to 0 and simplification is we will take first common outside. So, which terms are all common here? We can see here x plus 1 whole square is common here, x plus 1 whole square and x minus 3 whole square and 3 is common. So, let me take these terms first outside, factors these terms. So, 3 times of x minus 3 whole power 2 of x plus 1 whole power 2. So, what will be left over in the first one? It is x plus 1 whole cube. We have removed x plus 1 whole square. So, only x plus 1 term is left over. 3 is taken outside. X minus 3 whole square is also taken outside. Now, coming to second term plus x minus 3 whole power 3. We have taken x minus 3 whole square. So, x minus 3 is left over. 3 is taken outside and x plus 1 whole square is also taken outside. So, these terms is equal to 0. So, we are having 3 times of x minus 3 whole square of x plus 1 whole square, x plus x 2x, 2x minus 3 plus 1 minus 2. So, 2x minus 2 is equal to 0. Again we can take 2 common outside. So, 3 2s are already 1, 3 is there common outside. We will get 3 2s are 6 here. 6 times of x minus 3 whole square of x plus 1 whole square of x minus 1, since we have taken 2 common outside. Now, to check which interval the function is increasing or decreasing, we will make this one as we have to check whether this particular function is greater than 0 or less than 0, we should check it. So, if you see this term, this x minus 3 whole square is a perfect square term. So, this is always positive. So, the function this x minus 3 whole square is always positive and x plus 1 whole square is always positive. So here the function is depending only on, even 6 is also always positive. So, the function is increasing or decreasing is depending only on this term x minus 1. So, from the beginning onwards we no need to equate to 0 for finding the intervals, because we just when we factorized we found that at the end our f dash of x is nothing but 6 times of x minus 3 whole square into x plus 1 whole square into x minus 1. Here 6 is always positive, x minus 3 whole square is also always positive and x plus 1 whole square is also perfect square always positive. The function is depending only on x minus 1. So, we should check now whether the function is increasing or decreasing when the x is less than 1 and x is greater than 1, or which interval the function is increasing or decreasing. So, the number system is divided only into 2 parts. One is less than 1, positive 1, and another one is greater than 1. Here this is the only turning point we can think here. So, x is equals to 1 is a turning point here we can say. For other places f dash of x is always positive here. For x minus 3 whole square, x plus 1 whole square, these are all perfect square. So, let me check x is equal to 0. When we check x is equal to 0 in this one, we will get negative 1. So, the function is decreasing in the interval. There is only 2 intervals here, minus infinity comma 1 or 1 comma infinity. So, when we substitute 0 in this one, we can see this is positive, here 6 is also positive, 0 minus 1 is minus 1. So, it is negative. So, f dash of x is less than 0 for negative. for the interval where minus infinity comma 1 is there. So, for all the values x less than 1 the function is decreasing, and for all the value of x greater than 1 the function is increasing.